and it's because it still ends up being the same thing that I did, but when I have x plus h being replaced here, I forgot to replace it on one of the things. So they're asking you to use just any value of x to find out when the slope of this graph is going to be 0. So that means I have to, and actually I'll just make 2 copies. That means I have to replace, make 3 copies actually. That means I have to put this in brackets and subtract it. And then everywhere I see x, and this is where I made my mistake, is I forgot, okay, well whatever, I'll just get rid of it. I forgot to replace my x right there as well. And I have to now keep a copy again. And this is going to be cubed. Okay. And this is going to be minus 5 times x plus h. And this makes a big deal because you have to learn how to subtract these two eventually. And it looks like it makes a situation that's tough to solve. And it does, in a way. And we'll see how to solve it. Okay? So the first thing I have to do is distribute this. And that's going to be my rule of cubes. So it's going to be x cubed plus 3x squared h plus 3x h squared. And for this, go to consult Pascal's triangle. It's very handy to know Pascal's triangle. And then the whole third's going to distribute it. Okay, so I'm going to get a third there. These are going to cancel out. These are going to cancel out. And I'm going to get a third there. Okay, so that's going to be my whole left side. I'm just going to make it there. And maybe I'll color code it. This is that. And then you've got to distribute this. So you get minus 5h. I'll keep it in black. Minus, well, actually, yeah, minus 5h. Actually, I'll keep it in red. Minus 5h. Minus 5x. Minus 5h. And that is this. And this one, we just leave it as is. I'm going to just leave that as it is. Okay. And then it's all going to be minus this. Plus that. How did that become a plus? Because this minus has to distribute through the whole bracket. Let's plus that. I'll steal from here. And plus this. Okay. We're on our way now. So we're going to group or cancel our terms that can be canceled. So you see minus third x cubed and 1/3 x cubed. It just makes our life easier. Okay. When you do cancel one, make sure you cancel the other. And then over here, I'll get rid of that plus as well. X squared plus h. Can't get rid of it right now, but this one here and this one here I can cancel. Do I have any minus 5h? Not just yet. Okay. You might think, oh, I got to solve this, and you will eventually have to solve it. There is a way to resolve it, and that would be if you, for us to add all these terms, I have to have a common denominator. So clearly that's not going to work at this stage. Okay. And let's see if I can do it. And I'm just trying to remember what the question was asking. I think it's just asking us to resolve that. So I'm going to just keep my main equation here in case I have to go back to it. Okay. So I've got minus 5h, but I got no h's. Now, before I do that, before I resolve it, or try to resolve this part, because that's the tricky part, isn't it? I'm just going to leave it, and remember it's being divided by h. I don't know if that'll work at this stage. I think I have to find a way to resolve that, because otherwise it'll just be h distributed into it. No, I think it'll still work. So all of this is being divided by h, so let's have a look at what that means. That's the same as multiplying this whole thing by 1 over h. Okay, that might help actually. So when you're multiplying fractions, you just multiply all the numerators. Easy enough, right? That's just going to be the same thing at the top. And at the bottom, you have to multiply all the denominators. Well, I could do that, or I could see if there's an h in each of them. And there's not. So what I'm going to have to do is that's over 1, and that's over 1, and that's over 1. We'll just see if this works first. This might be the long way. And that's over that, and that's over that, and that's over that. Okay, so essentially I just distribute an h through each. Now I can get rid of that. We'll see if it works out. It might not, mostly because of this one here. Okay, so here I can see that these h's cancel. And here I can see one h is left up here. And here I can see two h's, so I'll write that as a 2, are left up here. And here I can see the h's cancel. And nothing cancels there, and nothing cancels there. And that's the problem, because for this to cancel out, I'd have to have an h up there. So clearly I'm missing a little key step somewhere, because for us to add it, I would then have to multiply through to h again, and I'm still going to be left with the same problem that when h is a 0 down here, the whole thing doesn't cancel. So what I believe might be the solution, there we go, is that this, will that work? This can be rewritten, and that can be rewritten as 4 times x to the minus 1. I don't know if that'll work. No, it still won't work. So essentially we have to find a way of adding and subtracting these. If I put them like that, and no, that'll work. I'm allowed to change any one of these fractions by changing its denominator. See if that works. And you're allowed to change just one fraction in this thing, because if you don't change the fraction itself, you're not really changing the fraction in the equation. So how can you not change a fraction? You multiply by 1. Okay? Except I'm trying to make this have this on top. So I'm going to multiply it by x plus h. And I'm trying to have this, or have this beside it. So essentially I'm making these two common denominators. And it's a minus 4. So I'm going to multiply it by x. And now their denominators will be this. And I still have the same problem, I think. Oh no, I don't. Okay, there we go. Yes, I do. This will just have an... Oh no, I don't. We'll see. Okay, so that means all of this now is all over this denominator. Now if I distribute this, I get minus 4x, or sorry, plus 4x, plus 4h. That's the complicated part right there. Plus 4x, plus 4h. And you can see minus 4x plus 4x on top of this. It's got to stay on top of this fraction, because I've changed the fraction so that I can combine those two fractions. So that's what I'm left with. That's perfect. Now if you look, they all have h over the top. And try to remember that the whole thing is being multiplied or divided by h. There we go. And by the way, it's not. This is not being multiplied. It's still being added. And it's a plus now because remember the minus 4x. Oh, actually, you know what? I should have distributed through. I had to treat that. No, I could treat it like a plus minus. That still works. It's a little tricky. So when I put the minus in next to the 4, I actually should have distributed times every. No, it was only next to the 4. And then I essentially added the minus 4. It's hard to explain that part. But anyway, I'm now multiplying the whole thing by 1 over h instead of dividing by h. And you can see this cancels with this one, with this one, with one of these, and with one of these, and with this one. So I'm going to get rid of this h at the bottom. Now you might say, well, I still have an h at the bottom, but that's okay because it's h plus x. So I'm left with x squared plus xh plus h squared over 3 minus 5 plus 4 over x plus h times x. Okay, when h approaches 0, I'm left with this. What does that become? 8x squared. So I'm left with x squared minus 5 plus 4 over x squared. And it looks pretty weird, for sure. If I was to make a common denominator on all of these, I would make this x to the 4 minus 5x squared plus 4 all over x squared. Either of these answers is correct. This is the derivative. It'll find me the slope. And now remember, we were going to find when the slope is flat. Okay? So either one I can set to 0. I'm going to put this one aside for now and set this one to 0. Okay, how do I get rid of this denominator? I multiply by both sides by a reciprocal. It becomes 0 over here, and it cancels out over here. So I'm left with this. So clearly I'm looking for a factor that reaches plus 4, but multiplies or adds up to minus 5, multiplies out to plus 4. And I'm talking about minus 1 and minus 4. So the factor's here, and you might say it doesn't have a factor that's x to the 4. No, it's x squared minus 1, x squared minus 4. So that is the factored version of this. Okay, so far, so good. So only that fraction was freaky. And you might say, well, that doesn't work out. But yeah, let's go ahead and expand it. So remember what we factored from? Let's see what we had. We had this. So I'm going to put that aside and expand it to make sure I still get this. X to the 4, yeah. Minus 4x squared, minus 1x squared, minus 5x squared, yep. Plus 4, yep. So that is indeed the expansion. So x squared minus 4, x squared minus 1, x squared minus 4, I'll put the x squared in a second, x minus 1, bracket, is so far what we have. Yeah, I know it seems hard. You've got to do more and more of them. So the squared and the squared. Now, how do you figure out what x is? To make 0, well, you set each of these individually to equal 0. Because if either one of these brackets is 0, then the whole thing is 0. So you just solve for x squared. You get that. How did I get that? Because minus 2 squared is 4 and plus 2 squared is 4. Great. So now I have 4 distinct points. Does that make sense for a trinomial? No, it doesn't. For a cubic, it doesn't actually. So I might have made an arithmetic error, which means I'd have to do this whole thing again. But essentially what it would mean is I go through minus 2. No, it doesn't. It means there's a flat spot there at minus 2. A flat spot there at minus 1. A flat spot there at 1. Yeah, it's impossible. Flat spot there at 2. But that's not a cubic. So it shouldn't have come out with positive. It should have only had come out with 2 of them. So that's interesting. So I'm going to make sure I got the right derivative. So I'm going to cheat. So this one is x. The derivative is actually x squared minus 5. And indeed, it's minus 4x to the minus 1, which becomes plus 4x squared. No, that is correct. That is the derivative. So let's set this to equal to 0 and try again. Okay. Yeah, it ends up being the same thing. Because to get this alone, first you have to put this on this side. So it becomes minus. Then you have to multiply it by x squared to get x squared to the other side. And you get x4 minus 5x squared plus 4. It ends up being equals 0. Yeah, it's the same thing. So you end up with x squared minus 4 x squared minus 1. So technically, you should have a minus 1 or a plus 1, minus 2 or a plus 2. That will be true. It will create a flat for this. Oh, you know what? That is not a cubic because of this over here. If I was going to put this all in the same denominator, I'd have to multiply it through, and I'd get x to the 4 minus 5x squared minus 4x. Yeah, I think that's the secret. It looks like a cubic, but it's not. Let's let Desmos find our flats for us. Why ain't it coming up with my graphing calculator? There we go. And I'm just going to let y is equal to it. Power 3 minus 5x minus 4 over x. Yeah, there you go. So that stupid x here created an asymptote, and thus my math was telling me that I was indeed correct, but my brain was telling me I was still living in the cubic world. But because of this x, it creates an x can't be 0, and my cubic, if this x hadn't been there, watch what happens when that x is not there. See, it's a cubic. But because of that x, it creates an asymptote. So while this cubic was normally coming down to here and connecting, it suddenly got ripped apart, sent up there, and sent down there, which created 2 extra bumps. So make sure when you look at this, you recognize here. So I should have trusted my instincts and said that minus 2 minus 1 plus 1 plus 2 are indeed peaks of the curve. And that's what a slope of 0 means. And so I should have then plugged it in here and let it solve it. But when you reach that point, just have this equal that and then solve it like this. 1, now you've got that point. 2, now you got that point. Minus 1, now you got that point. Minus 2, now you got that point. Notice the symmetry, by the way. They're perfectly symmetrical. Through the origin. They're, what's that called? Odd. And if you label the points, you'll see them. See? So I can just take a picture there. And so clearly if I put it into the calculation, it would have been a pain. It would have been stayed in fractions. And you can either work out the fractions or not. But what you do is you put each value of x into the equation to spit out your y for each corresponding thing. I'm just not bothering with the long calculations. So that was a long way to get through that, but as you can see, you gotta trudge through the mud to get to the forest.